Let's solve a physics question here. The question is, a 2000 kilogram steel box in the below figure is supported by two ropes. What is the tension in each rope? As you can see in the diagram here, I guess this is a ceiling. And you can see two ropes here in orange. And they're hanging a steel box here. So this is a steel box. So as you can see, the first rope is forming a 20-degree with the vertical. The second rope is forming a 30-degree with the vertical here. So what are you looking for here? The question is asking for the tension of each rope. So when you're looking for tension, you're basically finding the force. So what do you need to do? What's the concept of force? Now we're to look back at Newton's law of motion. Okay, so now what we really need to know is that, what we really need to find out is that, right? What we know is the net force acting on the object, which is a steel box here, has to sum up to 0 to reach equilibrium. So how do I say it? So the net force, right, is basically the sum of all the forces has to be equal to 0. So all the forces acting on this steel box, this object here, has to be equal to 0 from any directions. Okay, so what does it mean? Well, it also means that, right? Let's say that's the sum of all the forces. So now let's break it down into the x component and the y component. So the sum of all the forces in the x direction has to be equal to 0. And it also means that the sum of all the forces in the y direction has to be equal to 0 as well. So if you add these two up, it's equal to 0, because 0 plus 0 is also equal to 0, right? Okay, now how do we find the forces in the x direction and the y direction? Now, first of all, we have to draw a free body diagram. So let's draw a free body diagram. So let's look at the steel box as a point, okay? So let's look at the object as a point. So here, as a point. So now look at what are the forces acting on this point. Well, right away, we do know that there are two ropes hanging. So there are two tension force acting on this object. So it's pulling up here, right? So that's 20-degree forming with the vertical and 30-degree forming with the vertical. So let's draw this. So we can draw this here. This is 1. This is tension 1. And here, this is the second one, tension 2. Okay, so we know these two forces. What other forces are there? There's one force there that we know for sure is, although we cannot see it, but we know for sure is, that's gravity force pulling the box downward. Right? Yes. So there's a gravity force here. So we can draw a vector that's straight down. And let's call this Fg. Stands for gravity force. Okay, so it's acting downward. Otherwise, this object will be flowing around in the air, right? But that's not how it works, right? Okay, so are there any more forces acting here other than these three forces? Are there any forces acting on this steel box here? Are there any forces coming from the side, like the left and the right, or anywhere? No. Are there any forces pushing the box up here? Are there any forces like, is there a normal force? Well, there are tension force, the two tension force pulling up, but there's nothing else pushing the box up from here. So there's no normal force either. Okay, at this point, the box is just hanging still there. It's not moving anywhere anyway. So really, for this to keep the box stationary there is really the two tension force here and the gravity force pulling down. So basically, these two tension force, the sum of these two tension force will offset with the gravity force, so that this box stays here. That's not moving. Okay, so now that's all the forces there. So let's draw a Cartesian plan along this and take a look at it. Okay, so here, this will be the x-axis. and this will be the y-axis. So y and x. Okay, from here, what do we know? Now we do know that this vector here, so this tension 1, can form a right triangle here and a right triangle here. And this tension 2 can form a right triangle here and a right triangle here. Okay, we do know that from this diagram here, rope 1 is forming a 20 degree with the vertical, and rope 2 is forming a 30 degree with the vertical. So I can write this. So over here, this is 20 degree angle, and over here is 30 degree angle. Okay, so you can see that. Okay, so over here, we have to break it down into the x component and the y component. So we do know that the x component will be coming from here, right? That's the x-axis for the tension 1. So here. So if to look at it from here, so we can also see it as here. So let's draw it like this here, right? So it can also be here, right? We can see that. So the x component for tension 2, right? Basically here, 2, right? So here is equivalent to here. Here is equivalent to here. So what is the y component? Would be this one. That's the y component for the 2 tensions. So you can see this as here. Okay, let me write it down like this, draw it like this, right? And that's the y component here of the tension 2. So let's see, right? This is tension 1 in the x direction, but this is the negative x-axis. So I have to write it down as negative T1x. And this is the x component of the tension 2. And it's in the positive direction. I have to write down as T2x, right? It's positive direction on the x-axis, but it's negative direction on the x-axis here, right? But how about the y component for both tension here? Well, they both are in the positive y-axis. So you can write this as T1y, right? The y component, and this one is T2y, because they're all in the positive direction, positive axis of the y-axis, positive direction of the y-axis. Okay, now we don't know, right? I mean, this is just a sketch of the free body diagram. We don't know how long the vector is for T2 and how long the vector is for T1 right now, right? They don't necessarily like meet each other. Like the head of the vector don't necessarily meet each other horizontally, right? Because depending on how long the tension is, or what's the tension, and then it determines the magnitude of the vector. Okay, but that's just a sketch of the free body diagram. Okay, so we can look at it this way. And how about FG? Well, this is always in the negative direction because this is a negative y direction here, right? So it's negative value. The gravity force is negative value. Okay, so now we have all the forces sketched out in the free body diagram. Now let's write down in the equation, right? Let's look at the sum of all the forces in the x-axis here. Okay, so let's write down the sum of all the forces in the x-axis. How do I write this? What force do we have in the x-axis? Right here. In this negative direction in the x-axis is negative T1x. Okay, so negative T1x. And in the x direction on the positive side, it has T2x, tension 2, right? The second rope, the tension of the second rope with the x-axis. So plus T2x. X should be subscript. Okay, so, right? Tension 1x component is in the negative direction. Tension 2x component is the positive direction. Okay. Of course, right? We have to look at the gravity force in the x direction here. So we have to plus the gravity force in the x direction. That's it, right? There are only 3 vectors here. 1, 2, 3. So I write them all down, right? And that's supposed to sum up to 0. Now, next, look at all the forces from the y-axis. Now you can see that, okay, so from the y-axis, there are two tension force too, right? As well. So T1y and T2y, but they're all in positive direction. So I can just write down T2. Okay, the first one is T1. T1y plus T2y, right? So it accounts for these two forces. How about this gravity? Yes, the gravity is in the y-axis, right? So we have to add the y direction of the gravity force, and that's supposed to sum to 0. Okay, now we have write down the general equation, right, of all the forces for each component here, the x and y component. Next thing what we have to do is write down in equations, like in actually numbers, right? So how do you determine this, right? This value here. Okay, let's look at this. Let's look at the forces in the x direction first. Right? How do you determine negative T1 x value? Now we do know that here you can see a right triangle here, right triangle here, right? And there's a right triangle here, right triangle here. Basically, this triangle is equivalent to this triangle, and this triangle here is equivalent to this triangle. Okay, so we can look at it in either way. So now, since this is a right triangle here, right? According to the trigonometry, right? We do know that for this angle, we know that this is 20 degrees. For this, right, sine 20 degrees here is equal to opposite over hypotenuse. So to get the opposite side, you have to take hypotenuse divided by, you have to take the hypotenuse times sine angle here to get this component. Okay, so it's negative T1 because this is tension 1, right? This vector is tension 1. So I will not take the x subscript anymore because this is just the x component of the T1. But now to represent the x component of T1 is basically negative T1 times sine 20 degrees. Okay, now plus, how about T2x? So tension 2 in the x direction. So tension 2 in the x direction, which is this one here. So how do you, basically it's the same as this one, right? This one is basically this one, 2, right? They're the same. So how do you get that? Well, same idea here, right? So this is a right triangle. In order for you to get this component, in order for you to get sine, for this angle, right, sine 30 degrees opposite over hypotenuse. But then if you want to get this component, it is hypotenuse times sine 30 degrees. Hypotenuse is T2. So T2 sine 30 degrees. T2 sine 30 degrees. Now, gravity force in the x direction. Is there anything? Well, as you can see, the gravity force just straight down in the y direction. There's nothing in the x direction. It's vertical in the y direction. So in the x direction, there's no gravity force, right? So Fg subscript x is 0. Now, of course, right, it's equal to 0. Now, next, write out the forces in the y direction in the equation. So sum of all the forces in the y direction. What's that equal to? What's T1y? T1 subscript y. This one, right? So basically right here, but you can look at it from here. So from this triangle here, what do you see? Well, from trigonometry, you know that adjacent over hypotenuse give you cosine of this angle. So to get this component here, the adjacent component, you have to take hypotenuse times cosine this angle, 20 degrees, to get the adjacent component here, adjacent base here of this right triangle. So you know that this is T1 cosine 20 degrees plus, what is T2 subscript y? It's basically this one, right? It's also here, but I write here, so it's equivalent to this, right? So looking at this triangle here, to get this component here, you do know that from trigonometry, adjacent over hypotenuse give you cosine of this angle. So to get this component, right, the adjacent side of this triangle, you have to take hypotenuse times this cosine 30 degrees. So it's T2, right? Because this hypotenuse here is the vector T2. So T2 cosine 30 degrees. Now, gravity, right? In the y direction. Is there anything? Yes, there is. But it's in the negative y direction. So it's supposed to be a minus, right? So because it's a negative y direction, it's minus. Minus FGY. Of course, that sums to 0 right here. Okay, now you can start solving this. Now, what do you know from here? What is gravity of y? Because you're looking for tension, the two tension here. So these two are the variable, T1 and T2. How about Fg subscript y? So let's write this here. Fg subscript y. What's that equal to? How do you calculate the gravity force? It's basically the mass times the gravity, right? Acceleration. So basically mass times the acceleration downward due to gravity. What's the mass of the object? 2,000 kilogram. And what's the gravity? Negative 9.8 meters per second square. So this is m times g, right? And that's equal to, mass is 2,000 from the question, right? Kilogram times gravity is rounded as 9.8 meters per second square. So what is that equal to? Now we do know that 2,000 times 9.8 using calculator is 19,600. Okay, so we can just replace this here, right? Okay, let's do it step by step. So let's look at this equation here first, okay? We can rewrite this. Let's put in the calculator to get the value of sine 20 and sine 30, and then we can let's calculate to decimal. Then we can easily just do the calculation later, okay? So this is here. Sum of force in the x direction is basically equal to, okay, what's sine 20 degrees in decimal? So sine 20 degrees is 0.34, around that to 0.34, but it's negative sign here, so it's negative 0.34, right? Tension 1 plus sine 30 degrees. What is that in decimal? 0.5. 0.5 tension 2, right? Plus 0 is just 0, so we don't care. So this is 0. Okay, next. This equation here. Let's evaluate this. Cosine 20 degrees is, in decimal, round it up, right? It's actually 0.939 something, but let's round up to 0.94. Tension 1 plus, what's cosine 30 degrees? Cosine 30 degrees is around 0.866, but let's round up to 0.87, right? T2. And minus, okay, so minus, let's say here, right? This is gravity force. We calculate that in the y direction is 19600. And of course, that's equal to 0 from the original equation. Now, you have a system of equation. These two equations here, right? These two equations here, you can solve for T1 and T2. So what do you do? Now, first of all, maybe isolate one variable and then substitute that into another equation, and then solve for one variable first, and then you can find out the other variable, because the question is asking you to find out the value of T1 and T2. Okay, so it's easier to isolate variables in the first equation here. Okay, so let's use this equation. So we know that if we move this negative 0.34 T1 to the right side, so this one here, right, we have 0.5 T2 is equal to 0.34 T1, because when you move this negative value to the right side, it's become positive. Isolate T2, right? So we can substitute T2 here. So divide both sides by 0.5. So what is T2 equal to? So 0.34 divided by 0.5 is 0.68. So 0.68 T1. So we can substitute this one into T2 in the second equation. Then we can solve for T1. Okay, so let's do this. So this equation, let me just ignore this symbol here. So I will write this 0.9 for T1 plus 0.87 T2 minus, okay, so minus 19600, you add to both sides, then this will be cancelled out and you have this equal to 19,600 on the right side. And what is T2 that we say is 0.68 T1. So I can do this. Plus 0.87 times T2 is here, right? This one, 0.68 T1 is equal to 19,600. Now we can solve for T1. Okay, so 0.94 T1 0.94 T1 plus what is 0.87 times 0.68? It's 0.5916, but round it up to 0.59. T1 is equal to 19600. Now, you can add these two together, right? They're like terms. 0.94 plus 0.59 is 1.53 T1. T1 is equal to 19600. Then what is T1? Take 19600 divide by 1.53. It's around 1,200. It's about 12,810, right? Just round it up to whole number. Okay, the unit is Newton. Okay, so now you have T1 calculated. How do you calculate T2? Now let's go back to this simple equation here. T2 is actually equal to 0.68 T1. So we know that T2 is equal to 0.68 T1. And we calculate T1 already to be 12810. So to calculate T2, we just substitute 12810 into T1. And T2 is equal to 0.68 times 12810. Round it up to a whole number, 8,711 Newton. Okay, so here's your answer for the tension. So tension one is the tension one. So the tension of the first rope is 12,810 newtons, and the tension for the second rope is 8,711 newtons. Okay. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.